Now, a projectile is fired at initial velocity u and angle alpha to the horizontal. The plane P passes through the point of projection and makes an angle B beta with the horizontal. If the particle strikes the plane P at right angles to P after time t, show that. Okay, so I have to show this here. Okay, so there's a couple of rules in there. Everything's been changed to tan, so it's going to be so. Oh dear. The end of the question, like just ignore that for the time being, and just concentrate on making your four equations and doing exactly what they asked you. All right. Now, keyword here is strikes at right angles. What does that mean? If it strikes the plane at a right angle, what does that mean? Yeah, no Vx value. Vx is gone, right? So you're going up, coming down, and you're pretty much hitting it like that at 90 degrees, okay? So Vx equals 0 at the same time, Sy equals 0. They have the same time value, okay? So we're going to be able to compare those two time values with each other. Alright, we need to find the t value. Then once we find the t value, then we need to create this equation here, right? So let's do that. Everybody happy with angle alpha? And the usual u cos alpha and u sine alpha for the projection? U cos alpha and u sine alpha. Next thing I need to do is make my gravity triangle. Does it give me the angle of the wedge? Beta. Okay. Or the angle of the plane. So you can be beta for gravity, which is g cos b and g sine b. Everybody okay with that? Yeah. Oh, excellent. Oh yeah, that would explain the alpha minus beta. It is indeed. Well done. Sorry guys. If you look at the keywords here, it says angle alpha to the horizontal. So that's actually not alpha. Alpha would be these two angles combined. Very weird. All right. So alpha is actually this angle here combined with this angle here. Alpha is both of them combined. So alpha equals the yellow angle and the blue angle combined, right? But we know that the blue angle is beta. So this would make the thrown angle alpha minus beta. Okay? So instead it's going to be u cos alpha minus beta and u sine alpha minus beta. There's a hint in the answer, wasn't there? The way that there's alpha minus beta in the answer, so there was a hint there, so you can get why. Now, let's make our four equations. What's Vx, lads? U cos alpha minus beta. Take away. Ready? Yeah. Gt sine beta. Okay. Vy is u sine alpha minus beta minus gt cos beta. I'm doing my change the lines trick, okay? Then Sx is ut cos alpha minus beta minus a half gt squared sine beta. And finally, Sy equals ut cos ut sine alpha minus beta, a minus b, minus a half gt squared cos b. Right. Presentation wise, I think I could do with bringing that down. Oh no. All right. Now, going to do two things. I'm going to do Vy equals 0, and then I'm going to do, phi x equals 0, and then I'm going to do sy equals 0. I'm going to do both of them. See what happens. Alright. So, phi x equals 0. And then let's work on that. So, we're going to work on phi x equals 0. So, that's going to be in green. So, it's going to be u cos a minus b. Then I'm just going to bring over the gt sine b. It's going to equal gt sine beta. And then the time of flight, TOF, T value, if you will be u cos a minus b divided by g sine b. Alright, that was all phi x equals 0, and that's put away there. Next thing I'm going to do is go for sy equals 0. So sy equals 0 will be located here. Okay. So sy equals 0 will be it'd be ut, so it'd be, you just bring the half gt squared cos beta over the other side. So we're going to end up with ut sine a minus b equals a half gt squared cos beta. Cancel the t's. So multiply it and we get gu sine a minus b over g cos b. I believe that's what I was asked to prove, wasn't it? Go up. I was asked to prove this, wasn't I? Okay. Deduce next that 2 tan alpha. So the next part I'm looking at is this here. How are you going to do that? Well, I do have two key pieces of information here. I know that this one here equals this one here. The two of them are equal to each other. And my job is going to be make as many tans as possible, isn't it? Because everything has to be converted to tan for the next part of the question. So I'm just going to convert everything into tan where I can. So we're going to have a next part of the question. Next part of the question, which we'll do in red pen. So it's going to be u cos a minus b over g sine b equals 2u sine a minus b all over g cos b. Now, I'm looking to make sine over cos, sine over cos. So what would be my move? Get rid of that, get rid of that, get rid of that, get rid of that. Where am I going to move to cos a minus b? Anybody? It's multiplication on the left, which will make it division on the right, the first part. And then this g sine b, which is multiplication on the left, will, division on the left will be multiplication on the right. And then long behold, 1 equals 2 tan a minus b, tan b. All that's to do, was it? There's another part, isn't there? I believe there's another part. Alright. If a minus b equals pi over 4, find in terms of u and g the range of the projectile along p. Okay. Whenever we agree that range is time of flight inserted into Sx. Does it matter which time of flight I use? Shouldn't. So I'll just pick one of them. It shouldn't make a difference. I'll just pick the top one. I'll just pick this one here to throw in. So I'm going to write down the SX equation here. I'm going to reduce the size of this as well. Well, group. All right. So go again. So first thing I'm going to write down is SX. I'm going to write down SX without the T value. This is going to be U length T cos A minus B. Minus a half G. Now, let's put in the top one. This is not going to look good. It's going to be pretty bad. This is going to be U cos A minus B. Everybody got that? Over G sine B. Now, what happens when I square this here? What happens if I square that? We're going to need to square it over here. So what do you reckon? U squared cos squared A minus B all over G squared cos squared B. Right, and you're looking at that and going, what have I got myself in for here? This is ridiculous, right? We all good? I'll try and make it a bit bigger. Did you make a mistake? What am I using? I'm using this one. Oh, sin squared on the bottom. Ah, perfect. Thank you. That would have made my life considerably easier, more difficult. So, is everybody happy with G squared, sin squared B on the bottom? Perfect. Thank you. Now, all right. Now let's multiply this out. Absolute monstrosity, all right? So U squared. Would everybody be happy with cos squared A minus B? Cool with that? And then after that is actually we're actually just going to turn out quite nicely in a second. Just have to remember this going out very nicely now. That G cancels with that G, and then we end up with U squared cos squared U squared cos squared A minus B all over 2G. Now answer that sine beta and one of these. Cancel, don't they? Just leaving G sine beta on the bottom. Very quick fix here. They're very similar. So what can I do here? Just that, isn't it? And then what do I have at the end then? Sx equals U squared. Yeah, no, I'm about to sub it in over. Right. Now it gives me a vital piece of information though. What's the piece of information it gives me? The question. A minus B equals pi over 4. Now, it says find in terms of U and G. What's the issue here? Did I get rid of beta? Did I specifically get rid of G sine beta? So I'm gonna test out something in a second, right? Don't worry, have my eyes on it. Okay. Now there's one thing that doesn't belong. This won't belong, but I can get rid of this. So what can I do? Cos squared pi over 4. Does anybody know what pi over 4 is or what it means? Yeah, it means 45 degrees. Pi is 180. So pi over 4 is 45. Just remember that in future. If we see pi, it means 180 degrees. We're going to put in 45 in a sec. So it's going to be Sx equals u squared cos squared 45 over 2g sine beta. Now we're going, still doesn't meet the criteria of the answer, does it? Now, what I'm going to do next is I'm going to go up to the time of flight I didn't use. Which was the time of flight I didn't use? Anybody? Yeah, and look, just after seeing it now. Alright. I haven't done a single thing wrong, so don't worry about it. Could have been quicker. Now, what can I do here with this formula here? Any guesses what I can do with this? Come on, you will guess. What am I going to do with the a minus b? 45. What's 2 tan 45? 2. What's tan b? Tan b is a half, yeah? Using the right angle triangle technique, 1 over 2. Hypotenuse is, what is it? Root 5. Go all the way back down the bottom. What do I want to get rid of again? I want to get rid of that sine b, don't I? So, what do we do then? Sine beta is 1 over. Got it. How do I know it didn't belong in the answer? Well, it didn't mention beta in the answer. It says in terms of u and g, which means I'm not allowed beta. Okay? Or b, I'm not allowed b. So it means I had to get rid of it. What did I say it was again? 1 over root 5? Alright, so this is now u squared cos squared 45 all over 2g 1 over root 5. Alright, in the calculator, here's what I'm going to put in. I'm going to put in cos squared 45. I'm going to put in the 2. I'm going to put in the 1 over root 5. I'm going to see what I get. So it's going to be cos 45 squared divided by 2 divided by 1 over root 5. And the answer is syntax error. I didn't close the bracket the second time. I should have had this on the outside of this. There you go, root 5 over 4. So the answer I'm getting is root 5 u squared over 4g. Alright? Cool. Question.